Welcome, my dear students, to Standard 10 class Science and Technology Part 1. We begin with the numericals of heat. Before that, I would like to bring it to your notice about the experiment on page number 78. Based on that, we have the first numerical. Take 3 spheres of iron, copper and lead of equal mass. Put all the 3 spheres in boiling water in the beaker for some time. That means equal heat is given to all these 3 spheres. Take the 3 spheres out of the water and put them in the wax. That means the box of wax. You will see that the depth of each sphere is different. This indicates that the absorption of the heat of each sphere is different. The conclusion of this experiment is the specific heat of all the 3 spheres is different, which means that the heat absorbing capability of all the 3 spheres is different. That means the heat absorbing capacity for iron, copper and lead is different. Based on this, we have the first numerical over here. On page number 72, we begin. I read a question for you, my dear children. Equal heat is given to 2 objects A and B of mass 1 gram. Temperature of A increases by 3 degrees Celsius and B increases by 5 degrees Celsius. Which object has more specific heat and by what factor? Now we will see what is given. Equal heat is given to 2 objects, that is object A. We will name this object as A and this object as B. So both the objects have mass 1 gram. Temperature of A increases by 3 degrees Celsius. The increase in temperature of object A is 3 degrees Celsius and object B is 5 degrees Celsius. So we will write down what is given to us. Given mass of object A is 1 gram. Then here we have C, we don't know. That is, which object has more specific heat is to be found out. So C we don't know, it was denoted by a small c, specific heat. Delta T is given to us, which is the difference in the temperature, is given to us as 3 degrees Celsius. Here in object A, in object B, we have mass as 1 gram, specific heat we don't know of B and here A, and delta T is given, difference in temperature is given to us as 5 degrees Celsius. Since both the objects have been provided with equal heat, the increase in temperature will be delta T, that is the difference in the temperature. Now we'll find out heat for both the objects, that is QA is, we'll use the formula QA is equal to MC delta T. We substitute the values. M is 1 gram. C, that is specific heat of object A, we don't know, we are supposed to find out, and delta T we have 3. We substitute the values where we have QA, that is heat of the object A, is equal to 3CA we get. We name it as equation 1. Then for object B heat we have same formula MC delta T. Then you have mass of the object is given as 1 gram. Then specific heat we do not know of B and 5 degrees Celsius is delta T. That is equal to, we have 5 CB. Now, we have QB, that is equation number 2. Now, since both are given same heat, from 1 and 2 we can write, from 1 and 2 we equate the heat of object A, that is 3 specific heat of A is equal to 5 specific heat of B. Now we'll see what is asked. Which object has more specific heat? We'll find out the specific object of A first, that is CA is equal to this. When it is changing the side, it changes the sign. That means this multiplication becomes division. So 5 upon 3 we have, and CB. CA is equal, that means specific heat of object A is equal to 5 upon 3, which is 1.67 CB. Now we'll find the specific heat of for object B, which is CB is equal to, this 5 will go this side, so this will be 3 upon 5 CA. This will, when you divide, you get 0.6 CA. Now, since 1.67 is greater than 0.6, we have specific heat of object A is greater than the specific heat of object B. Now, by which factor it is greater? By 5 upon 3. That means, why? Because specific heat of object A is 5 upon 3 times the specific heat of object B. So the factor will be 5 upon 3, and the specific heat of object A is greater than specific heat of object A is greater than specific heat of object B. Therefore, we say, and by which factor? By 5 upon 3 factor, which is over here. Before we begin the numericals, in this lesson, we need to understand certain formulae. Now, suppose we have ice, which is a solid, and ice has to be converted into water. Here, we are changing the state. The solid ice is converted into water, which is liquid. For this transaction, we use the formula Q is equal to ml, where Q is the heat, m is the mass, and L is the latent heat of the substance. Whereas in this case, when 20 degrees Celsius water is converted into 10 degrees Celsius water, both in the liquid state, that is only the temperature we are changing over here, we use the formula for this transaction as Q is equal to mc delta T, where Q is the heat, m is the mass of the substance, C is the specific heat, and delta T is the change in the temperature or the difference in the temperature. Now, only these two formulae we are supposed to use in these numericals of heat. We begin with the second numerical, which is on page number 72 of your textbook, my dear children. Liquid ammonia is used in factory for making ice from water. If water at 20 degrees Celsius is to be converted into 2 kg ice at 0 degrees Celsius, how many grams of ammonia are to be evaporated for this. Now, liquid ammonia is used in the ice factory for making ice. If water is at 20 degrees Celsius, it has to be, and the mass of the water is given to us, it has to be converted into 0 degrees Celsius ice, and for that transaction the ammonia needed to be evaporated is asked. Now we will see what is given to us, my dear children. Given 20 degree Celsius water has to be converted into ice, but before that we have to convert this 20 degree Celsius water. 20 degrees Celsius water is to be converted into ice. Now this 20 degrees Celsius water we convert into ice by transforming into water, 0 degrees Celsius water first, and then it will be converted into 0 degrees Celsius ice, which is a solid. Here this water 20 degrees Celsius is liquid and this is liquid. As I told you, when the temperature is changed and the state is same, we will use the formula mc delta T for this. And here when we are changing the state, we will use the formula Q is equal to ml. Now we will see what is given to us. Here for ice conversion into, that is water conversion into ice, and then here for ammonia, mass is given to us as 2 kg of ice. When we convert, we have 2000 grams of ice. Here we are supposed to find out ammonia, which we suppose it as m grams of ammonia. Then we have specific heat as of ice as 1 calorie per gram degree Celsius. Here we are not concerned with. Then T1 and T2, that is 20 degrees Celsius water has to be converted into 0 degrees Celsius ice. Here we don't have to do anything with ammonia. Then latent heat we have of ice as 80 calorie per gram, that is, it is standard, and latent heat of ammonia is given to us as 341 calorie per gram. Now first the 20 degrees Celsius water has to be converted into 0 degrees Celsius ice. For this we have two transactions. This water has to be converted into 0 degrees Celsius water first, and then that 0 degrees Celsius water has to be converted into 0 degrees Celsius ice. Now for this we will have Q is equal to, we will name this as Q1 and Q2 since we have two transactions over here, Q1 plus Q2. Now we substitute the values. Now for Q1 we have the formula M, that is M is what now, 2000 is given to us. Then C is 1, delta T we have 20 minus 0, and then plus you have ml, that is 2000 into L is 80, that is latent heat of ice. That is equal to 2000 into 20 minus 0 is 20 plus 8 2s are 16, 1 2 3 4 zeros, 1 2 3 4 zeros. Here you have 2 2s are 4, 1 2 3 4 zeros over here, plus 16, 1 2 3 4 zeros over here. Then 16 plus 4 is what? 20, and the remaining zeros we place 1, 2, 3, 4 zeros we have here. This heat we are supposed to take it from 20 degrees Celsius water to convert into ice. Now for this transaction, ammonia we are wanting ammonia. That is why it is asked how much ammonia is needed for this transaction. So for that, now liquid ammonia is to be transformed into, I'm writing it here, liquid ammonia has to be transformed into the vapor. That means here the change of state is been taking place. Liquid ammonia is to be changed into vapor, and that is why you use the formula Q is equal to ml. For change of state, we're supposed to use this formula, and that is equal to mass we don't know, Q we know, we found out 20 into latent heat is given to us 341, and mass is equal to 1, 2, 3, 4 upon 341, that is equal to 0, 0 upon 341 into 1000, that is equal to 586.4 grams.